everyone. Today we are going to learn about the law of sines and how to solve triangles when we are given the ambiguous case of SSA. Before we get started, I would like you to please go ahead and complete these two warm-ups. The first warm-up question is 8x to the third power plus 27y to the third power. And the second one is 36x squared minus 25y squared. Please factor each of these questions on your own. And when you have an answer, please go ahead and restart the video and we will see how well you did. All right, the first question is what we call a sum of cubes. And the way that we factor a sum of cubes is with a binomial times a trinomial. So I'm going to take the cube root of the first term, and that's going to give me a 2x. And then the cube root of the second term is going to be a positive 3y. Then I'm going to use these terms to do square opposite product square. So 2x squared, that's going to be 4x squared. The opposite of a plus is a minus. Product is 2 times 3, which is 6, and then an xy. And then squared, 3y squared is 9y squared. So plus 9y squared. For the next problem, this is a dot. It's a difference of two squares, and I'm going to split it up into two binomials, two parentheses, taking the square root of each term. So I'm going to have a 6x, and then I'm going to have a plus 5y, and then a 6x, and a minus 5y. So hopefully those were easier examples for you. If you are still struggling with factoring, please make sure that you come and see me as soon as possible so we can have a conversation about factoring. So our learning targets for today is for you to be able to say, I can solve any triangle using the law of sines if I am given SSA. So what SSA looks like is that you're going to receive a triangle, and you're going to, let's call this triangle ABC, and let's say that you know what little a is, you know what little c is, and you know angle A. That is called SSA. That's where the angle is not in the middle of two sides. So that's not the information that you know. Instead, you just know two sides and an angle that is not included. I also want you to be able to say, I can follow the flow chart for the ambiguous case of SSA to determine whether or not 0, 1, or 2 triangles exist given side-side A or side-side angle. So the SSA case is called the ambiguous case for a reason. And that's because even though we're working with the law of sines and we have two of a kind, you would know like angle A and its opposite side of side A, two of a kind means that we get to use side-side angle. Sometimes, based on the information that's given to us, the information doesn't make sense, meaning that we could end up with no triangle existing based on that information. Or we could end up with one triangle existing based on that information. Or the really tricky part is that two triangles could exist. So whenever you are given SSA, which you'll need to be able to recognize the difference between getting angle side angle or angle side and side angle. So you'll need to make sure that you recognize when you're given specific information. So it says, caution needs to be exercised when using the law of sines in the SSA case. Depending on the relationship between two sides, we'll call them A and B, and the height, there exists an equation for height. This means height equals B times the side of angle A. So height, the height of your triangle is going to be equal to what we call the other side. This is how we're going to refer to B times the sine of A. This is called the other side times the sine of your given angle. So your height, so depending on how the height is related to your two sides, there could be no triangle, one triangle, or two triangles, like I just said. It just depends on your information. So what we're going to do is we're going to consider a triangle when you are given two sides, and we're going to call those two sides A and B, and you're given capital A, which means that you're given angle A. By fixing side B and angle A, you can sketch the possible positions of side A to figure out how many triangles can be formed. Now in the diagrams below, please note that height is equal to B times the sine of A, and we're going to start with A being obtuse. So right down here we have A being obtuse, and then we'll have A being acute. For this portion of the lesson, I would strongly recommend that you have out some colors, whether it's highlighters or colored pencils, just so that you can see what's going to be taking place. So starting with the easy side of our side-side angle flow chart, let's talk about A being obtuse. So if A is obtuse, and you're told that the side opposite of angle A is less than or equal to the side of the other side, we'll call it, then that means that no triangle exists. You would have 0 triangles. And we would say that no triangle, no full triangle could exist. So therefore, there's nothing for you to do for those types of problems. Think about it. If you have yourself a triangle, and let's say that I'm going to draw my angle right here, and I'm going to call this angle 100 degrees, and I'll say that this is angle A. And so we know that the measure of angle A is equal to 100 degrees, and I'm telling you that little a is equal to 10, and little b is equal to 12. And I call this part right here B, and so that would mean little b would be right here, and it's 12, and then on the other side would be 10. We'll call that little a. I can't draw a full triangle. The reason why I can't draw a full triangle is because I know, based on my knowledge of geometry, that whenever you have a large angle, whether it's obtuse or a right angle or just simply the largest angle of the triangle, the largest angle of a triangle needs to be across from the longest side. We have across from the right angle is always the hypotenuse, the longest side of the triangle. And in this case, they're saying that the longest side of the triangle is side B, not the side opposite of the obtuse angle. Therefore, that means that this side doesn't really touch the corner of B. It doesn't form a triangle. It almost forms a triangle, but not quite. So therefore, no triangle could exist. Let's go ahead and look at the next one. The next one says, if you know that the opposite side is bigger than the other side that's given to you, and we know that angle A is obtuse, then there's only one triangle that can be created. Only one triangle is possible. So then there exists this other case. What happens if A is equal to B? So let's say that I tell you that the measure of angle A is equal to 100 degrees, little a is equal to 10, and little b is equal to 10. Okay, so I'm going to draw my obtuse triangle, and I'm telling you that little a is equal to 10. This is 100 degrees. This is angle A. Little a, and I'm telling you that this is little b, and it's equal to 10. Well, if we know that these two sides are congruent to one another, what that means is that we have ourselves an isosceles triangle. And based on our knowledge of geometry, we know that if we have an isosceles triangle, then that means our base angles have to be congruent. So that would indicate that angle B would also have to be 100 degrees. But that doesn't make any sense because we know that all of the angles of a triangle add up to 180. And we know that just going 100 plus 100, that equals 200 degrees. And now, what are we really talking about here? Are we really talking about a triangle? No. So that's the reason why A cannot equal B, and A is not allowed to be smaller than B. Instead, A has to be bigger than B if you have an obtuse angle that is given to you. So we have ourselves a flowchart that you will be allowed to use on your test. So this exact flowchart, kind of written out in a nicer and neater way, I suppose, is going to be given to you on your test. And so I'm just going to focus on the one side. So how do you deal with this flowchart? Well, the first question is the angle given to you obtuse or acute? We're going to work with the obtuse side first. Let's say that you are given an obtuse angle. So that's your given angle. The next question you have to ask yourself is the side opposite of the given angle greater than the other side? If the answer is yes, then we have ourselves one triangle and it follows the pattern that we have up here. If the answer is no, then that means no triangle exists and there is no work to show. If the answer is one triangle, then you will have to solve that one triangle. You'll solve that triangle using the law of sines and follow the exact same steps that we used in the last lesson. but it just depends on the information that is given to you. So that is the first side, the obtuse angle. So now, this is where it gets a little bit more complicated. What if you end up getting an acute angle? Let's say that A is acute. So you have angle A, side A, and little b. And then we have to insert the h, the height. And so it's all about a relationship between the side that's given to us, the height of the triangle, and another side that's given to us. So let's say that you find out what the height is. Now remember that the height in these types of problems is equal to b times the sine of angle A. So b represents your other side times the sine of your given angle. So if we calculate the value of our height and we find that the side opposite of our height is shorter than our acute angle, is shorter than our height. So the side that's opposite of our acute angle, if that side is shorter than our height, then that means that no triangle is possible. So no triangle exists. So you might have to calculate your height whenever you're analyzing your information. If you find that the height is the exact same length as little a, the side that's opposite of angle A, then that means that only one triangle exists, and that triangle has to be a right triangle. And the reason why that is because a height comes from it being perpendicular with the ground. So if your height and your opposite side ends up being the same exact length, then we only have ourselves a right triangle. And if we have ourselves a right triangle, then that means we can work with SOHCAHTOA, we can work with Pythagorean theorem. And so that's the time when you have only one triangle. What happens whenever we have our height is less than A, which is less than B? This is where it gets a little bit trickier. So this is where I want you guys to take out your highlighters. So in the event that your height is smaller than A, smaller than the side that is opposite of your acute angle, but your acute angle, the side that's opposite of your acute angle is smaller than your other side, what we have here are two triangles that exist. Let me go ahead and write down that two triangles exist. And let me show you what those two triangles are. First, we'll have a big triangle. A big triangle exists. That could mean that angle B is simply bigger than angle A. That's okay. You're allowed to have that. Angle A is acute. Angle B is allowed to be bigger than an acute angle. That could happen. So we have ourselves one big triangle. And whenever you are drawing your triangles and you know that you're going to end up with two triangles, I want you to always draw your triangles in the exact same way, where A is in this bottom corner, and then you have angle B, and then angle C is going to be up here. And then little a is going to be across from angle A, little b is going to be across from angle B, and then little c is going to be down here. This is our big triangle that we will draw. And this big triangle can be acute, it can be obtuse. It just depends on what you have. But one thing that I want you to know is that in your large triangle, two things are going to be constant. Number one, angle A is going to be acute. And number two, angle B will also be acute. So in your large triangle, when you draw it, your side that is given to you, you always draw your angle that's given to you down here, and then your other angle or the other opposite side that is given to you, so meaning like if they give you little b, we draw angle B down here. If they give you little c, we draw little c down here. So we want to make sure that we are, we want to draw angle C right here. So we want to make sure that we are consistent. Once again, if they give you angle A, we always put the angle that is given to you in the bottom left-hand corner. And then you'll write your opposite side, and then some other side might be given to you. They might give you the letter B, they might give you the letter C. regardless of that letter, it's going to go right here on the side. So if this is supposed to be a little b, then opposite corner will be angle B. If they give you a little c, then your opposite angle will be angle C. So whatever the opposite angle is supposed to be down here. So the one thing I need you to know is that angle A will be acute in this triangle and angle B will also be acute in this triangle. There exists another triangle, and this is where it gets a little confusing. A lot of kids would like to say that the other triangle that's going to be given to us is this isosceles triangle. But remember that you are given little b, and angle A. And so the other triangle that has little a, angle A, and little b is this smaller obtuse triangle. So this is the other little triangle that you will receive. So I'm going to try to draw that picture for you. This is the other triangle that I would expect you to draw. Let me see if I can draw it. A good job. So I would call this angle A. I'd call this little a. Here's little b and angle B. And once again, we'll have our height. Our height would be located inside of our big triangle, and our height is going to be smaller than little a, but little a will be smaller than little b. Out here, your height is going to be located outside of the triangle, and if you guys can envision this, your height is located outside of this small triangle. And your height, in this case, is still going to be shorter than little a, but little a is going to be shorter than little b. So I'm going to use a highlighter to highlight this small triangle. The one thing that I want, or the couple things I need you guys to know is that number one, angle A is still going to be acute, and it's still going to be the same exact measure as it was. So will little a and so will little b. But angle B, the angle that's opposite of the side that's given to you, this angle right here is going to be obtuse. Not only will it be obtuse, but this angle B is going to be supplementary with angle B in the large triangle. So it's going to be supplementary with B in the large triangle. So supplementary means that it adds up to 180. So I said to you guys, in this larger triangle, your opposite angle is going to be acute. Well, it's going to be obtuse in this triangle, and it's supplementary with the previous. And so that's just a little rule that you need to know. The last big triangle that I want you to be aware of is if you are given that angle A is acute, and you're given that little a is bigger than the other side that's given to you, then only one triangle exists. Only one triangle is possible. But the one thing I want you guys to know is that this triangle will not be a right triangle. So it will not be a right triangle. So we will still be working with the law of sines. Okay, so I recognize that this is a lot of information, so we have ourselves a flow chart, and once again, you will receive this flow chart on your test. So you're going to ask yourself, is the given angle in your information obtuse or acute? This time around, it's acute. And if it is acute, then you have to ask yourself the following question. Is the side opposite? So let's say that the acute angle that's given to you, let's pretend that the given angle, you're given the measure of angle A. That means that the side opposite of the measure of angle A is little a. And you want to ask yourself, is little a greater than or equal to the other side that's given to you, whether it's B or C? So let's call it B for our purposes. If side A is greater than or equal to the other side, then we only have one triangle, and we are going to be drawing a triangle very similar to what we have up here. Only one triangle exists, and it's just going to be a larger triangle. If the answer is no, then we need to check that we have ourselves the other side. Is the other side times the sine of our given angle which is our height, that's what we're checking right here, is the other side, B, times the sine of our given angle, is that value smaller than our opposite side? So we want to come up with a number at this step. Identify what your height is and ask yourself, is our opposite side greater than the other side? If the answer is yes, then we'll have to draw two triangles just like we drew up here. If the answer is that they are equal to each other, then that indicates that we have one right triangle. So if the answer is yes, then that means that A is going to be greater than B times the sine of like angle A, and that's a number that we're going to end up getting. If they're equal, if A is equal to B times the sine of angle A, then that means that A is equal to your height, and we have ourselves a right triangle, and only one right triangle would exist. If the answer is no, then that means that we have no triangle exists. So if you end up with A is less than B times the sine of angle A, then that indicates that we have ourselves no triangle. So this is something that I want you guys to please make sure that you know and study, and it's going to make a little bit more sense once we actually start doing some examples. So please make sure that you know and study this entire chart. So everything that you see on this page, please make sure that you know and study. Although you will receive this chart on your test, it's in your best interest to make sure that you understand it. Let's go ahead and flip the page. So looking at our next example, I have triangle ABC. We want to solve triangle ABC with angle A being 94 degrees, little a being 18, and little c being 13, being the length of 13. So we have to look at the angle that's given to us. The angle that's given to us is 94 degrees. So this is an obtuse angle. So that means I'm going to be working with the obtuse side of our flowchart. And I'm also going to draw an obtuse triangle. So I'm going to call this, I'll make my obtuse angle up here, and here I'll call this B, and I'll call this C, and my obtuse angle is 94 degrees. And my little a is going to be equal to 18. My little c is going to be equal to 13, and so c in this case is going to be called our other side. So we're going to go through the flow chart. Number one, we are given an obtuse angle. So we're given an obtuse angle. That is check, which means that I'm going to be working with the left-hand side of my chart. Okay, so according to my left-hand chart, I'm given an obtuse angle, and I have to ask myself, is the side opposite greater than the other side? So our side opposite of our obtuse angle is 18. Is 18 greater than the side that's given to us, which is 13? And since 18 is indeed greater than 13, then that indicates we got a yes. And since we got a yes, that means that one triangle exists. Cool, so we know that one triangle exists. So the nice thing is that we can now solve this triangle. So remember that in solving a triangle, we want to identify what the measure of angle A is, what the measure of angle B is, what the measure of angle C is. And we want to find what little a is, what little b is, and what little c is. So I'm going to write what little a is, what little b is, and what little c is. So unfortunately at this point we only know one of our angles, so we can't use the 180-degree rule. So instead we're going to be working with inverses in order to help us to identify what our missing angles are. I think it might be beneficial for us to probably identify what angle C is first, since we're going to be working with our given information. So I know that little c is 13, and I can find what angle C is by just using the law of sines. So I'm going to write 18 divided by the sine of 94. That's going to be equal to 13 divided by the sine of angle C. So now I'm going to use cross product, and I end up with 13 times the sine of 94 is equal to 18 times the sine of angle C. My goal is to get angle C alone and away from sine. So I'm going to start off by dividing both sides by 18. So I end up with 13 times the sine of 94 divided by 18 is equal to the sine of angle C. So how do you get the sine away from angle C? Well, what you have to do is you have to take the inverse of both sides. So it's kind of like, how do you get rid of multiplication? With division. How do you get rid of subtraction? With addition. How do you get rid of a sign? With sign inverse. And the way that we write sign inverse is with a sign to the negative first power. And so that's going to be sign inverse. And what a sign inverse does is it eliminates the sign, leaving us with the measure of angle C. So in my calculator, if you want to calculate the sign inverse, you'll see sine inverse, cosine inverse, and tangent inverse. And I'm interested in sine inverse, so I'm going to press second. So I'm going to press second sine, and in my calculator, I'm going to enter in everything that I see, and I'm going to be very careful entering it into my calculator. So I'm going to write 13 times the sine of 94. I'm going to close my parentheses and then divide it by 18. And then close my parentheses again because I'm done with my full fraction. And then I'm going to press enter, and I end up with 46.09. But because this is an angle, I'm going to round it to the nearest whole degree. And the nearest whole degree is going to be 46 degrees. So this is 46 degrees. So I know that the measure of angle A is 94 degrees. The measure of angle C is 46 degrees. And I can find the measure of angle B very easily now. So the measure of angle B, that's going to be equal to 180 minus 94 minus 46. And 180 minus 94 minus 46, that is equal to 40 degrees. So angle B is equal to 40 degrees. So now I can use angle B in order for me to find what little b is. And I'm only going to use my given information. So my given information is 94 degrees and the 18. And recognizing that there could have been an error that takes place, I'm going to be grading this holistically, recognizing that you might have messed up along the way. And as long as you are consistent with your work, you will receive credit for your answers. So I already know that little a is 18, little c is 13, and I want to find what little b is. And so I'm going to use 18 divided by the sine of 94. That's going to be equal to little b divided by the sine of 40. So now I'm going to use cross product, and I have 18 times the sine of 40 is equal to little b times the sine of 94. I'm going to divide both sides by the sine of 94 and put that whole quantity into my calculator. And when I do that, I end up with b is equal to 11.6 units. So my answer is going to be 18 units for little a, 11.6 units for little b, and 13 units for little c. And I have officially solved my triangle. Let's go ahead and look at example number 3. In example number 3, we have ourselves triangle ABC, where little a is 77 degrees, angle A is 77 degrees, little a is 6.1, and little b is 9. So this time around, I am given an acute angle. So I'm going to follow my flow chart before drawing anything. So the first thing I'm going to do is I'm going to identify the fact that I am given an acute angle. Check. Second thing I need to do is I need to analyze my letters. So looking at my letters, the question is the side opposite, which the side opposite of angle A is little a, is that greater than or equal to the other side? So is 6.1, which is my other side, greater than or equal to, or my opposite side, greater than or equal to my other side? No, it is not. So now I'm going to look at the next part. So I have the answer of no. So now I need to come up with what is the length of my height and compare that with the opposite side. So my height is the other side times the sine of my angle. So I'm going to write h is equal to my other side, which is 9, times the sine of my given angle. And 9 times the sine of 77, that is equal to 8.77. So now that I have my number, I'm going to ask myself, is my opposite side, which is 6.1, greater than 8.77? Well, unfortunately, the answer is no. So because I ended up with no again, and I ended up with a no and then a no, that means that no triangle exists and there is nothing to draw. There's nothing for you to do. So you can probably anticipate what example number 4 is going to be about, but we still have to go through our check step. So the first thing I'm going to do is identify the fact that I'm given an acute angle, little a is equal to 10 and little b is equal to 15. So the first thing that we do is our checklist. First of all, we are given an acute angle. So because we're given an acute angle, the next thing I'm going to do is look at my opposite side. We would anticipate little a being my opposite side and b being the other side. Is 10 greater than or equal to 15? The answer to that case is no. So that means we have to identify our height. Our height, that is going to be equal to our other side, which is 15, times the sine of our given angle, which is 30. 15 times the sine of 30 is equal to 7.5. Okay, so step number 4, is 10 greater than 7.5? The answer is yes, it is. So that means that 2 triangles exist. So now this is where it gets very sticky. Because we know that 2 triangles exist, we need to draw out those 2 triangles. Here is the first triangle. The first triangle is going to be our big triangle, and then we work with our little triangle. So it's always big and then little. So our big triangle. I'm going to draw my big triangle down here. Now, based on my information, angle A is given to me, and I always draw my given angle down into the left-hand corner. My opposite side is A, and that is equal to 10. My other side is 15, and I always draw it on the side, and that's going to be equal to little b. So that means that angle B is right here, angle C is up here, and little c is down here. And what we need to do is we need to solve this triangle. So I'm going to identify what angle B is, and then I'm going to identify what angle C is, and then I'm going to identify what little c is. So the first thing I'm going to do is identify what angle B is, and the reason why I'm going to do that is because I already know what side B is. So remember that when law of sines, we're working with 2 of a kind. So I already know 2 of a kind. I already know that little a is 10, and I'm going to divide it by the sine of angle A, which is 30, and I'm going to set it equal to little b, which is 15, divided by the sine of angle B. And once again, in order for me to find angle B, I'm going to be working with inverse. So I'm going to use cross product, and I have 10 times the sine of angle B, that is equal to 15 times the sine of 30. I'm going to divide both sides by 10. And then in order for me I end up with the sine of angle B is equal to 15 times the sine of 30 divided by 10. And in order for me to get angle B alone, I'm going to take the inverse of the other side. So that means the measure of angle B is equal to the sine inverse of 15 times the sine of 30 divided by 10. And I'm going to put that entire quantity into my calculator exactly as I see it. And I find that the measure of angle B is equal to 49 degrees. Okay, so in my big triangle, so far I know that the measure of angle A is equal to 30 degrees. Now I know that the measure of angle B is equal to 49 degrees, and I now need to find what the measure of angle C is. So in order for me to find the measure of angle C, I'm going to take 180 and subtract 30 and then subtract 49. And 180 minus 30 minus 49 is equal to 101 degrees. So this time it just so happened to be an obtuse triangle, which is fine, but the most important thing is that this angle opposite of the side that is considered the other side, based on our given information, is an acute angle. That's the most important thing. This needs to be an acute angle. Angle C or whatever the other angle is can be anything we want it to be, or it can be anything, and it doesn't matter what it ends up becoming. But the most important thing is that this angle down here is acute. So now we know that little a is equal to 10, little b is equal to 15, and now we need to find what little c is. So in order for us to find what little c is, I'm going to use that information about angle C and the law of sines. So now so this is step number 2, and so here's step number 3. So I'm going to write 10 divided by the sine of 30, working with given information again, is equal to is equal to little c divided by the sine of angle C, which is 101 degrees. I'm going to use cross product, and I have 10 times the sine of 101 is equal to c times the sine of 30. I'm going to divide both sides by the sine of 30 and put that entire quantity into my calculator. And when I do that, I find that little c is equal to 19.63 units. Putting units at the very ends of all of my answers, I am officially done. So that's 19.63 units. Cool, I just worked with the big triangle. So now I'm going to work with the little triangle. So working with my little triangle. So this was my big triangle information. And now I'm going to work with my little triangle. So what does my little triangle look like? Well, it's going to be an obtuse triangle. It's going to be obtuse. So I'm going to try to draw a nice, neat, obtuse triangle. Once again, angle A is going to come down here. It's still 30 degrees. Little a is still going to be 10. I'm still going to call this angle B. And little b is going to be equal to 15. Here's angle C and here's little c. So I have my big triangle and I have my little triangle. And there's a few relationships that I'm going to refer back to on the last page. So the first relationship is how to find all of my angles. First of all, I said that angle B, if this angle down here is supposed to be obtuse, it's supplementary with our answer that we got from our big triangle. So if I'm trying to identify all of my information, my measure of angle A I already know is equal to 30 degrees. The measure of angle B I can find rather easily. I already found that the measure of angle B in my smaller triangle is 49 degrees, and these two angles need to be supplementary. So the measure of angle B, that's going to be equal to 180 minus 49, and 180 minus 49, that is equal to 131 degrees. So this is 131 degrees. If you were to use the law of sines in your calculator, once again, you're going to end up with 49 degrees. You'll end up with the same exact answer, and that's because of the fact that when we get into a deeper understanding of the unit circle and how reference angles work, you'll find that your answer will always be a number that is in between 0 and 90 degrees. But because this is an obtuse angle, it means that they are supplementary with each other. So that's going to be 131 degrees. Now we're going to identify the measure of angle C working with our 180 degree rule. We know 2 out of the 3 angles. We can find that the measure of angle C is equal to 180 minus 30 minus 131, working with the angles that we already know and working with our 180 degree rule. And 180 minus 30 minus 131 is equal to 19. So this time around, the measure of angle C is equal to 19 degrees. Notice that measure of angle C was 19 degrees in our obtuse angle, and it was 101 in the larger angle, and they're not related in any way, shape, or form. So they can be, there doesn't exist any sort of special relationship. It kind of goes along for the ride. So now we need to identify what our side lengths are. So we have little a, little b, and little c. Little a I already know is 10, little b I already know is 15, and little c, now that I know what angle C is, I'm just going to work with the law of sines. So my law of sines says I'm going to work with given information, and I'm going to write 10 divided by the sine of 30. That's going to be equal to little c divided by the sine of angle C, and angle C this time is 19. I'm going to use cross product, and I have c times the sine of 30 is equal to 10 times the sine of 19, and I'm going to divide both sides by the sine of 30. And when I do that, I find that little c is equal to 6.51. So I end up with 10 units for letter A, 15 units for letter B, and 6.51 units for little c. And this is all of my answers for my small triangle. And that is my answer. All right, that is the end of today's lesson. So The things that I want you guys to make sure that you understand and take from this lesson is how to draw your triangles. Please make sure that if you recognize that you're going to end up with 2 triangles existing, that you are consistent with how you draw them. Make sure that that consistency ends up staying with you throughout your homework, as well as when you take your test. That's number 1. Number 2, please make sure that you understand, and you know, and you study your flowchart. That is incredibly important, because this flowchart will be given to you on your test, but it will mean nothing unless you have practiced with it, used it, and you understand it. Not only will this flowchart be given to you on your test, but so will these pictures up here. So please make sure that you understand and you study this table as well. But that is the end of this lesson, and please feel free to email me if you have any questions over anything. Otherwise, I hope you have a wonderful day.